Hello students, today we'll start algebra of matrices. Algebra of matrices means first we'll discuss about the addition of matrices. Second will be your subtraction of matrices. Third one is scalar multiplication of a matrix. Now see, first and second addition of matrices and subtraction matrices, these two are very simple, and scalar of matrix, scalar multiplication matrix also very simple. So when you add matrices, maybe two matrices, maybe more than two matrices, when you are going to add the matrices, then they must have same order. And the same way for subtraction also, when you subtract two matrices, then in the case of subtraction also, the matrices must have same order. So for example, number 1, if matrix A equal to 2, 3, 5, 3, minus 1, 7, matrix B equal to 0, 1, 1, 3, minus 1, minus 1. See, this matrix is order 3, row 2, column 3. So row 2, column 3, both are having same order matrices. Therefore, you can find the addition. Therefore, A plus B, the addition of the two matrices, you can name with a new name. You can name the sum of the two matrices matrix C. So C will be what? Now, how to add the two matrices or how to subtract two matrices? So corresponding elements you have to add, or in case of subtraction, you have to subtract the corresponding elements. So when you add the two matrices A and B, the two you have to add with the, this is first element, here also first element is 0. So add 2 and 0, 2 plus 0 is here 2 only. Next you go to this element, the first row and second column, then here this is first row and second column. So add these 2, 3 plus 1, 4. The same way 5 will add to 1, 6. That means in case of addition subtraction, simply you add the corresponding elements of all the matrices, you will get the addition or subtraction of two matrices. The first row finished. Now second row elements, you is 3 plus 3, 6, minus 1, it will be minus 2, 7 minus 1, it is 6. It's a matrix, and the matrix order will be same of the given matrices. The sum or difference is same, and if you find A minus B of the two matrices, you can name with a new name, you can give matrix D. The subtraction here we are finding. So when you subtract, here also subtract the corresponding elements. The 2 minus 0 will be 2, minus 3 minus 1, 2, then 5 minus 1, 4. Down is a 3 minus 3, 0, minus 1, and minus 1, if you subtract, it will be 0, 7 minus 1, it will be 8. This is subtraction of the matrices. Now for scalar multiples of matrices, see, this is subtraction here, scalar multiplication of a matrix. Scalar multiplication means let matrix A equal to 4 minus 1 3 2 6 6, the matrix. Therefore you multiply the matrix with a real number, suppose minus 2. The matrix A will be multiplied with the real number minus 2. So this is called scalar multiplication. This is here matrix A is multiplied with the real number minus 2, and this is called scalar multiplication of a matrix. So when you multiply any matrix with any real number, that means you are going to multiply each and every element of the matrix with that real number. So here you have to get minus 2 at this new matrix, you have to multiply each and every element of this matrix by minus 2. So minus 2 matrix will be what? Minus 8, this will be 2, this will be minus 6, this will be minus 4, this will be minus 12, and this will be also minus 12. This is a matrix. You can name this matrix as matrix B. So these three are very simple: addition of matrices, subtraction matrices, and scalar multiplication matrices. These are very simple. Here you give the numbers like this. Now number 4 is multiplication up to matrices. So this you have to try to understand. Multiplication of matrices, you have to follow the different rule when you are multiplying two matrices. The first condition should be what? Let is a matrix of order m by n, and B is a matrix of order n by p. So what we have noticed here, in the first matrix number of column, and in the second matrix number of rows. So in one matrix, if the number of columns is same with the number of rows of the second matrix, then we can find the product then this product of the two matrices is possible, and the new matrix we can write. The new matrix will be the product of the matrices A and B, and the order will be what? As the number of columns of the first matrix is same with the number of rows of second matrix, so these two we have to eliminate. So what is left? First number of rows of the first matrix M is left, and here column of the second matrix is left, M and P. So the product matrix will have order M by P. Now take two matrices. Matrix A is matrix A, you are getting the order 2 by 2, and one matrix B is order 2 by 3. Now here you see, if you want to multiply these two matrices, so you must check the number of columns of the first matrix and number of rows of the second matrix. So here you see number of columns of the first matrix and number of rows of the second matrix, both are same, so the product of these two matrices is possible. That means A by A and B, these two product of these two matrices is possible. and the order of the two matrices after multiplication order will be, so this will be left and this will be left, because these two are same numbers, number of columns, number of rows, this you have to ignore, and the left out numbers will be 2 first and the last one. So these two numbers will form the order of the product of these two matrices, and order will be 2 by 3. Now how to multiply? Then the product of the two matrices will be 2 by 3. So therefore you write product of A and B. You write 2 minus 1, 3, 2. And here you write 3, 3, 0, 0, 1, minus 1. So when you find the product, in that case, you have to follow the rule of first matrix row and the second matrix column. Row elements and columns elements only have to multiply. First matrix you have to choose one row, and the second matrix you have to multiply elements of each and every column. So when you multiply, first you choose the first row. Always you have to choose the first row of the first matrix, and with the first row you have to multiply the elements of the first column, then you have to multiply the elements of second column, and then you have to multiply the elements of the third column. So after finishing that, then you have to go to the elements of the second row. With the second row elements, you have to multiply the elements of the first column, and you have to multiply the elements of the second column, and you have to multiply the elements of the third column. So start with the first row of the first matrix. The first row elements are 2 minus 1, and with the first row elements, I'll first multiply the elements of the first column of the second matrix. So what rule you have to follow when you multiply the elements of row and the elements of column? See, first row, first element is your 2. In the first column, first element is your 3. Here first element 2 and here first element is 3. So multiply 2 and 3. 2 and 3 I have multiplied. So first element finished. Then second element and second element. So what will be the symbol then here? You have to put here plus. After first into first, then plus sign, then second into second, plus sign, third into third, plus sign, like that. So here only 2 elements, and the column also 2 elements. So first element I multiplied, and second elements left of the first row and the first column. So in between those two you have to put the plus symbol. So now think about minus 1. With minus 1 second element, you multiply the second element of the column. So minus 1 into 0. Yeah. Done. So with the elements of the first row and elements of first column, product is finished. Now we have to go to the second column. With second column also you have to multiply the elements of the first row, and with the third column also you have to multiply the elements of the first row. The first you have to multiply the first row elements with each and every column of the second matrix. So the first row, first column, product finished. Now with the first row you go to the second column. The first element, 2 is the first element, and here 3 is the first element. So 2 into 3. Then first element finish, plus. Now second element and second element, minus 1 into minus 1. Sorry, minus 1 into 1. So first row and second column elements product finished. You have to leave the space, and again first row and third column product, leave the space. Then start multiplication of the first row and the third column. So I start with the first element here first element 2, here first element 0. So 2 into 0, first element finish. Now second element and second element, minus 1 into minus 1. So you enclose here. So with the first row elements, I have multiplied each and every column of the second matrix, and those will give you the 3 elements of the first row. So in that way you have got the 3 elements of the first row. From here you will get one number, from here you will get one number, here you will get one number. So we are getting the first row, all the 3 elements. Now go to the second row. So when you multiply the second row elements with each and every column, then those will give you the elements of in the second row. So now start with the second row elements. You multiply the each and every elements of the first column. So first element start 3 into 3. Then first element finish. Always give plus symbol. Now second element of the second row and second element of the first column, second matrix. So 2 into 0. So with the second row, first column finished. Now with the second row, you do the product with second column. So always start with the element wise. So here first element is 3 and here first element is 3. Leave the space, then start with the second column. So 3 into 3. Finished. First element finished, give plus here. Now second element and second element, 2 into 1. 2 into 1 finish. With the second row and second column product finish, leave the space. Now with the second row you find the product with the third column. So do the element wise. The first element 3 and here first element 0. Leave the space and write here 3 into 0. Here should be space, here space. 3 into first element finish. Now give plus here, then second element into second element, 2 into minus 1. So in that way I have got the elements in the second row. Now simplify this, you will get your matrix. 2 3 is 6, 0, and 2 3 is 6 minus 1, 5 second row, second element of the first row, and from here 1 third element of the first row. So in that way I have got the 3 elements of the first row. Now calculate the second row elements. Here it will be 9, and here will be 9 plus 2, 11, second element of the second row, and this will give you the third element of second row minus 2. So in that way I have got a product, and order is 2 rows and 3 columns. So it is 2 by 3. Order is 2 by 3 is coming. So in that way you have to find the product of 2 matrices. One more thing you have to note here. Here A is possible, A into B is possible, but BA is not possible. Why it not possible? If you start with B order is 2 by 3 and A matrix order is 2 by 2. So when you find the product, then the second number of the first matrix should be same with the first number of the second matrix. So number of columns of the first matrix should be equal to number of rows of the second matrix, but here you see these two are not equal. So therefore this product is not possible. So therefore AB is not equal to BA. If AB and BA possible. If AB and B are possible, then AB product, whatever matrix you'll get from AB and whatever matrix you'll get from BA, those will not be same if AB and BA product is possible. But here you see, in this case, the reverse product of these two matrices is not possible. Now take one question. Find a matrix A such that 2, 5 minus 3, 7 into matrix A equal to 17 minus 1 and 47 minus 13. So this matrix, it is unknown. This matrix you have to find, and this matrix is given. So left hand side is a product of two matrices, and we are right hand side, this is the product of these two matrices. And here product order, you see it is of 2 by 2 order, and the first matrix is the order of 2 by 2. Now to make the product valid in the left hand side, here you have to adjust the order of the matrix A. So this matrix A, see, to find the product, if the product is valid, then the second number of the first matrix must be same with the first number of the second matrix. Second matrix and first number order should be, if I add order here, then the matrix A should be of row, there must be 2 rows of the matrix A. Then this second number and this first number should be same, then the product is valid here. Okay, then what number you have to put here? Because the product order will be the first number and the last number only. First number and last number will be the order of the product. So order of the product is 2 by 2. That means this is the first number of the first matrix, and this should be the second number of the second matrix. So here it should be 2. So this matrix A you have to find here, and this matrix A must be of order 2 by 2. The right solution, let matrix A equal to, you write here A, B, C, D. It is 2 by 2 order matrix, and A, B, C, D, these are all unknown elements. You have to find their values. So write the product. Therefore 2, 5 minus 3, 7, then A, B, C, D equal to 17 minus 1, 47 minus 13. The left hand side you multiply these two matrices. So first element, start with the first row. With first row elements, multiply the first column elements twice, 2 into A twice A. First element finished. Now plus, now second element and second element, 5 into C, 5C. The first row, first column finished. Now leave the space. Now the first row elements go to the second column elements. The first and first twice B, give plus first and first. Now plus 5 second element and second element, 5D. The first row product finished. Now second row product. For the second row you find the product of the first column, the first element and first element, minus 3A plus 7C. First second row and first column finished, so leave the space. Now second row and second column, so minus 3B, again for minus 3B finished, plus now 7D. So with second row and second column finished, so the bracket and closed, and the right hand side matrix is 7 minus 1, 47 minus 13. So as these two matrices are same, so their corresponding elements will be equal. So therefore you write twice A plus 5C equal to 17, equation number 1. Then This you write minus thrice a plus 7c, which will be equal to 47, equation number 2. Then twice b plus 5d, this limit will be equal to minus 1, equation number 3. And then minus 3b plus 7d equal to minus 13, equation number 4. So here you see these two equations containing two unknowns, where a and c. When you solve these two, your solution will be a will be a minus 4 and c will be a 5. And when you solve these two equations in terms of b and d, then this will give b will be a 2 and d will be a minus 1. Therefore matrix A is A is your minus 4, B is your 2, C is your 5, and D is your minus 1. This is your matrix A. Now take another question. Find x if this matrix into this matrix, sorry, one more thing is there. One more matrix will be x 4 1 equal to 0. See, left hand side there are three matrices and they are in the form of product. This is the first matrix, second matrix, third matrix, and the product of all the three matrices is a 0 matrix. This is not a real number 0. This is This is 0 matrix. This is not a real number 0, because left hand side each and everything is matrix form. The right hand side is 0 should also be in the matrix form. That's why you have to turn this symbol as 0 matrix. Now you have to find the value of x. So there are product of three matrices left hand side, so you have to do product of two matrices first. These two product you have to find first. So this order is what? Row 1 column 3. This is order of 1 by 3, and this matrix is order 3 by 3. So product of these two matrices will be your 1 by 3. So product of these two matrices will be 1 by 3. First two product. Solution start. X minus 5 minus 1, 1 0 2, 0 2 1, 2 0 3, and here x 4 1 equal to 0. So when you multiply the first and second matrices, then it will be of order 1 by 3. That means only one row will be there. The product of these two matrices will give you a matrix where only one row will be there and three columns. That means like this, only row matrix. First matrix will give you a row because only one row is there, so it will be a row matrix from the product of the first two matrices. So multiply this first and second matrix now. So first element with the first row, multiply first column, then first row, second column, first row and third column, finished. Start here. So x into 1, x first row, first element, then second row, second element, then second element of the first row and second element of the first column, plus here minus 5 into 0 0, then third element and third element minus 2. The first row and first column finished, give the space. Now first row and second element, the element wise you have to multiply x into 0 0 plus minus 5 into minus 2 minus 10, then minus 1 into 0 0, and then again first row and third column, x into 2 twice 6, then minus 5 into 1 minus 5, and minus 1 into 3 minus 3. Finished. And here x 4 1 is equal to 0. The product of the first two matrices will give you x minus 2, then here minus 10, and here twice 6 minus 8, then here x 4 1, then here 0. After that, the product is coming for these two matrices. So when you multiply, here you see the order. This is the order is 1 by 3, and this is the order is 3 rows 1 column. The product of these two matrices will be your first number and last number 1 1. The product of these two matrices will be your 1 by 1 order. That means the matrix will contain only single element. So we multiply now. The first element and first element, x minus 2 into x first and first finish, plus second element and second element minus 10 into 4, plus third element and third element twice 6 minus 8 into 1. Through one row only and one column only, product is finished. And as the matrix will contain only one element matrix, it will be only one element matrix. So this single element will treat as single element only and enclosed by the bracket. Right hand side is your 0. So left hand side it is x square minus twice 6 minus 40, and then plus twice 6 minus 8 equal to 0. So it will be a quadratic equation, x square minus 48 equal to 0. This implies x square equal to 48. So x equal to plus minus 4 root 3. So we have finished the algebra matrices. Hope you all have understood. Now I will give some assignment. Please do it and submit your assignment in my personal WhatsApp number. Thank you and have a nice day.